Hi everyone and welcome to machine learning tutorial from GoLogica. In this video, we will understand machine learning and its basic advanced concept, especially designed to both students and experienced working professionals. This machine learning tutorial helps you gain a solid introduction to the fundamentals of machine learning and explore a wide range of techniques, including supervised, unsupervised, and reinforcement learning. So make sure you stick through the end of the video. Also, please don't forget to subscribe to GoLogica's YouTube channel to stay updated on trending technologies. Machine learning is a subdomain of artificial intelligence that focus on developing systems that learn or improve performance based on the data they ingest. Artificial intelligence is a broad word that refers to systems or machines that resemble human intelligence. Machine learning and AI are frequently discussed together, and the terms are occasionally used interchangeably, although they do not signify the same thing. A crucial distinction is that while all machine learning is AI, not all AI is machine learning. So here we have given the list of topics which we will be covering in this video. So kindly take a look. So, first, let's see what is machine learning. Arthur Samuel coined the term machine learning in the year 1959. He was a pioneer in artificial intelligence and computer gaming and defined machine learning as field of study that gives computers the capability to learn without being explicitly programmed. In simple terms, machine learning is an application of artificial intelligence which enables a program to learn from the experiences and improve themselves at a task without being explicitly programmed. For example, how would you write a program that can identify fruits based on their various properties, such as color, shape, size, or any other property? One approach is to hardcode everything, make some rules and use them to identify the fruits. This may seem the only way and work, but one can never make perfect rules that apply on all cases. This problem can be easily solved using machine learning without any rules, which makes it more robust and practical. You will see how we will use machine learning to do this task in the coming sections. Thus, we can say that machine learning is a study of making machines more human like in their behavior and decision making by giving them the ability to learn with minimum human intervention, that is, without explicit programming. Now, the question arises, how can a program attain any experience and from where does it learn? The answer is data. Data is also called the fuel for machine learning, and we can safely say that there is no machine learning without data. You may be wondering that the term machine learning has been introduced in 1959, which is a long way back. Then why haven't there been any mention of it till recent years? You may want to note that machine learning needs a huge computational power, a lot of data and devices which can store such vast data. We have only recently reached a point where we can now have all these requirements and can practice machine learning. Now let's see what are the features of machine learning. So here we have listed four features and let's see each in detail. Automation. Nowadays, in your Gmail account, there is a spam folder that contains all the spam emails. You might be wondering, how does Gmail know that all these emails are spam? This is a work of machine learning. It recognizes the spam emails and thus it is easy to automate the process. The ability to automate repetitive tasks is one of the biggest characteristics of machine learning. A huge number of organizations are already using machine learning with powered paperwork and email automation. In the financial sector, for example, a huge number of repetitive, data heavy, and predictable tasks are needed to be performed. Because of this, this sector uses different types of machine learning solutions to a great extent. This next comes improved customer experience. For any business, one of the most crucial ways to drive engagement, promote brand loyalty, and establish long lasting customer relationship is by providing a customized experience and providing better services. Machine learning helps us to achieve both of them. Have you ever noticed that whenever you open any shopping site or see any ads on the internet, they are mostly about something that you recently searched for? This is because machine learning has enabled us to make amazing recommendation systems that are accurate. They help us customize the user experience. Now, coming to the service. Most of the companies nowadays have a chatting bot with them that are available 24 into 7. An example of this is Eva from AirAsia Airlines. These bots provide intelligent answers, and sometimes you might even not notice that you are having a conversation with a bot. These bots use machine learning, which helps them to provide a good user experience. The next comes automated data visualization. In the past, we have seen a huge amount of data being get. Next comes automated data visualization. In the past, we have seen a huge amount of data being generated by companies and individuals. Take an example of companies like Google, Twitter, Facebook. How much data are they generating per day? We can use this data and visualize the notable relationships, thus giving business the ability to make better decisions can actually benefit both companies as well as customers. With the help of user-friendly automated data visualization platforms such as Autobus, business can obtain a wealth of new insight in an effort to increase productivity in their process. The last comes business intelligence. Machine learning characteristics, when emerged with big data analytics, can help companies to find solutions to the problems that can help the business to grow and generate more profit. From retail to financial service to healthcare and many more, machine learning has already become one of the most effective technologies to boost business operations. Python provides flexibility in choosing between object-oriented program or scripting. There is also no need to recompile the code. Developers can implement any changes and instantly see the results. You can use Python along with other language to achieve the desired functionality and results. Python is a versatile programming language and can run on any platform including Windows, Mac OS, Linux, Unix, and others. While migrating from one platform to another, the code needs some minor adaptations and changes, and it is ready to work on the new platform. So now let's see what is the need for machine learning in today's world. Machine learning is important because it allows computers to learn from data and improve their performance on specific tasks without being explicitly programmed. This ability to learn from data and adapt to new situations makes machine learning particularly useful for tasks that involve large amount of data, complex decision making and dynamic environments. Here are some specific areas where machine learning is being used. The first come predictive modeling. Machine learning can be used to build predictive models that can help business make better decisions. For example, machine learning can be used to predict which customers are most likely to buy a particular product or which patients are most likely to develop a certain disease. Natural language processing, which is also called as NLP. Machine learning is used to build systems that can understand and interpret human language. This is important for applications such as voice recognition, chatbots, and language translation. Computer vision. Machine learning is used to build systems that can recognize and interpret images and videos. This is important for applications such as self driving cars, surveillance systems, and medical imaging. Fraud detection. Machine learning can be used to detect fraudulent behavior in financial transactions, online advertising, and other areas. Recommendation systems. Machine learning can be used to build recommendation systems that suggest product services or content to users based on their past behavior and preferences. Overall, machine learning has become an essential tool for many business and industries as it enables them to make better use of data, improve their decision making process, and deliver more personalized experience to their customers. So, now let's see what is the history of machine learning. Nowadays, we can see some amazing applications of machine learning, such as self driving cars, NLP, and many more. But machine learning has been here for over 70 years now. Amazed, right? It all started in 1943 when neuropsychologist Warren McLeod and mathematician Walter Pitts wrote a paper about neurons and how they work. They decided to create a model of this using an electrical circuit, and therefore the neural network was born. In 1950, Alan Turing created the Turing test to determine if a computer has real intelligence. To pass the test, a computer must be able to fool a human into believing it is also a human. In 1952, Arthur Samuel wrote the first learning computer program. The program was the game of checkers, and the IBM computer improved at the game the more it played, studying which moves made up winning strategies and incorporating those moves into its program. Just after a few years in 1957, Frank Rosenblatt designed the first neural network of computers, which stimulates the thought process of the human brain. Later in 1967, the nearest neighbor algorithm was written, allowing computers to begin using very basic pattern recognition. In 1915, Alan Turing created the Turing test to determine if a computer has real intelligence. To pass the test, a computer must be able to fool a human into believing it is also a human. In 1952, Arthur Samuel wrote the first computer learning program. The program was the game of checkers, and the IBM computer improved at the game the more it played, studying which moves made up winning strategies and incorporating those moves into its program. Just after a few years, 1957, Frank Rosenblatt designed the first neural network for computers, which simulates the thought process of the human brain. Later in 1967, the nearest neighbor algorithm was written, allowing computers to begin using very basic pattern recognition. This could be used to map a route for traveling salesmen, starting at a random city but ensuring they visit all cities during a short tour. But we can say that in the 1990s, we saw a big change. Now, work on machine learning shifted from a knowledge driven approach to a data driven approach. Scientists began to create programs for computers to analyze large amounts of data and draw conclusions or learn from the results. In 1997, IBM's Deep Blue became the first computer chess playing system to beat a reigning world chess champion. Deep Blue used the computer power in the 1990s to perform large scale searches of potential moves and select the best move. Just a decade before this, in 2006, Geoffrey Hinton created the term deep learning to explain new algorithms that help customers distinguish objects and text in images and videos. So that's all about history of machine learning. Now let's see what are the types of machine learning. Machine learning is a branch of artificial intelligence, as you all aware of that. So we will explore what are the various types of machine learning algorithms that are important for future requirements. Machine learning is generally a training system to learn from past experiences and improve performance over time. Machine learning helps to predict massive amounts of data. It helps to deliver fast and accurate results to get profitable opportunities. There are several types of machine learning, each with special characteristics and applications. Some of the main types of machine learning algorithms are supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. So first, let's see about supervised machine learning. Supervised machine learning is defined as when a model gets trained on a labeled dataset. Labeled datasets have both input and output parameters. In supervised learning algorithms, learn to map points between inputs and correct outputs. It has both training and validation datasets labeled. Let's understand it with the help of an example. Consider a scenario where you have to build an image classifier to differentiate between cats and dogs. If you feed the datasets of dogs and cats labeled images to the algorithm, the machine will learn to classify between a dog or a cat from these labeled images. When we input new dog or cat images that it has never seen before, it will use the learned algorithm and predict whether it is a dog or a cat. This is how supervised learning works, and this is particularly an image classification. There are two main categories of supervised learning that are mentioned below. There are two main categories of supervised learning that are mentioned here. One is classification and the other is regression. In classification, with predicting categorical target variables which represent discrete labels or classes. For instance, classifying emails as spam or not spam, or predicting whether a patient has a high risk of heart disease. Classification algorithms learn to map the input features to one of the predefined classes. Let's understand it with the help of an example. Consider a scenario where you have to build an image classifier to differentiate between cats and dogs. If you feed the datasets of dogs and cats labeled images to the algorithm, the machine will learn to classify between a dog or a cat from these labeled images. When we input new dog or cat images that it has never seen before, it will use the learned algorithms and predict whether it is a dog or a cat. This is how supervised learning works, and this is particularly an image classification. There are two main categories of supervised learning that are mentioned here: classification and regression. In classification, it deals with predicting categorical target variables which represent discrete classes or labels. For example, classifying emails as spam or not spam, or predicting whether a patient has a high risk of heart disease or not. Classification algorithms learn to map the input features to one of the predefined classes. Some of the classification algorithms are logistic regression, support vector mission, random forest, decision tree, k nearest neighbors, naive Bayes. In regression, it deals with predicting continuous target variables which represent numerical values. For example, predicting the price of a house based on its size, location, and amenities, or forecasting the sales of a product. Regression algorithms learn to map the input features to a continuous numerical value. Some of regression algorithms are linear regression, polynomial regression, ridge regression, lasso regression, decision tree, random forest. So now let's see what is unsupervised machine learning. Unsupervised learning is a type of machine learning technique in which an algorithm discovers patterns and relationships using unlabeled data. Unlike supervised learning, unsupervised learning doesn't involve providing the algorithm with labeled target outputs. The primary goal of unsupervised learning is often to discover hidden patterns, similarities, or clusters within the data, which can then be used for various purposes, such as data exploration, visualization, dimensionality reduction, and more. We can understand this with the help of an example. Consider that you have a data set that contains information about the purchases you made from the shop. Through the clustering, the algorithm can group the same purchasing behavior among you and other customers, which reveals potential customers without predefined labels. This type of information can help business get target customers as well as identify outliers. There are two main categories of unsupervised learning that are mentioned here: clustering and association. In clustering, the process of grouping data points into clusters based on their similarity. This technique is useful for identifying patterns and relationships in data without the need for labeled examples. Some of the clustering algorithms are k-means clustering algorithm, mean shift algorithm, dbscan algorithm, principal component analysis, independent component analysis. Whereas in association, learning is a technique for discovering relationship between items in a dataset. It identifies rules that indicate the presence of one item implies the presence of another item with a specific probability. Some of the association rule learning algorithms are a priori algorithm, ECLAT, FP growth algorithm. Next comes semi-supervised machine learning. It is a machine learning algorithm that works between the supervised and unsupervised learning. So it uses both labeled and unlabeled data. It is particularly useful when obtaining labeled data is costly, time consuming, or resource intensive. This approach is useful when the dataset is expensive and time consuming. Semi supervised learning is chosen when labeled data requires skills and relevant resources in order to train or learn from it. We can use these techniques when we are dealing with data that is a little bit labeled and the rest large portion of it is unlabeled. We can use the supervised techniques to predict labels and then feed these labels to supervised techniques. This technique is mostly applicable in the case of image datasets where usually all images are not labeled. We can understand with the help of a small example. Consider we are building a language translation model. Having labeled translation for every sentence pair can be resources intensive. It allows the it allows the models to learn from labeled and unlabeled sentence pairs, making them more accurate. This technique has led to significant improvements in the quality of machine translation services. So, what are the types of semi-supervised learning methods? There are a number of different semi-supervised learning methods, each with its own characteristics. Some of the most common ones include graph-based semi-supervised learning. This approach uses a graph to represent the relationships between the data points. The graph is then used to propagate labels from the labeled data points to the unlabeled data points. Label propagation. This approach literally propagates label from the labeled data points to the unlabeled data points based on the similarities between the data points. Co-training. This approach trains two different machine learning models on different subsets of the unlabeled data. The two models are then used to label each other's predictions. Self-training. This approach trains a machine learning model on the labeled data and then uses the model to predict labels for the unlabeled data. The model is then retained on the labeled data and the predictor labels for the unlabeled data. The last comes generative adversarial networks, GANs. GANs are a type of deep learning algorithm that can be used to generate synthetic data. GAN can be used to generate unlabeled data for semi-supervised learning by training two neural networks, a generator and a discriminator. So the last type of learning is reinforcement machine learning. Reinforcement machine learning algorithm is a learning method that interacts with the environment by producing actions and discovering errors. Trial, error, and delay are the most relevant characteristics of reinforcement learning. In this technique, the model keeps on increasing its performance using reward feedback to learn the behavior or pattern. These algorithms are specific to a particular program. Example, Google self-driving car, AlphaGo, where a bot competes with humans and even itself to get better and better performance in Google. Each time we feed in data, they learn and add the data to their knowledge, which is training data. So the more it learns, the better it gets trained and hence it becomes experienced. Here are some of most common reinforcement learning methods. Q learning. In Q learning, it is a model-free oral algorithm that learns a Q function which maps states to actions. The Q function estimates the expected reward of taking a particular data in a given state. SASA, state action reward state action. SASA is another model free oral algorithm that learns a queue function. However, unlike queue learning, SASA updates a queue function for the action that was actually taken rather than the optimal action. Deep queue learning. Deep Q learning is a combination of Q learning and deep learning. Deep Q learning uses a neural network to represent the Q function, which allows it to learn complex relationships between states and actions. So let's understand it with the help of some example. Consider that you are training an AI agent to play a game like chess. The agent explores different moves and receives positive or negative feedback based on the outcome. Reinforcement learning also finds applications in which they can learn to perform tasks by interacting with their surroundings. So there are two types of reinforcement learning. One is positive reinforcement and negative reinforcement. In positive reinforcement, the rewards or the agent for taking a desired action, and it also rewards for the that particular action. Encourages the agent to repeat the behavior. Some examples are giving a treat to a dog for sitting, providing a point in a game for a correct answer. In negative reinforcement, it removes an undesirable stimulus to encourage a desired behavior. Also, it discourages the agent from repeating the behavior. Some examples are turning off a loud buzzer when a lever is pressed, avoiding a penalty by completing a task. See how to choose machine learning algorithm. There are plenty of machine learning algorithms, and it could be tough task to decide which algorithm to choose for a specific application. The choice of algorithm will depend on the objective of the problem you are trying to solve. So let's consider an example in front of us. Let's take an example of a task to predict the type of fruit among three varieties, that is apple, banana, and orange. The predictions are based on the color of the fruit. Imagine a picture that depicts the results of 10 different algorithms. The picture on the top left, consider there is a picture on the top left and it is called as a data set. The data is classified into three categories. Imagine any three colors like red, light blue, and dark blue. And there are some grouping. For example, from the second part, that is everything in the upper left belongs to the red category. In the middle part, there is a mixture of uncertainty and light blue, while the bottom corresponds to the dark category. The other image can depict different algorithms and how they try to classify the data. So now let's see what are the steps in machine learning. I wish machine learning was just applying algorithms on your data and get the predicted values, but it is not that simple. There are several steps in machine learning which are must for each of the project. The first step is gathering data. This is perhaps the most important and time consuming process. In this steps, we need to collect data that can help us to solve our problem. For example, if you want to predict the prices of the houses, we need an appropriate data set that contains all the information about past house sales and then form a tabular structure. We are going to solve a similar problem in the implementation part also. The next come preparing the data. Once we have the data, we need to bring it in proper format and pre-process it. There are various steps involved in pre-processing such as data cleaning. For example, if your data set has some empty values or abnormal values, example a string instead of a number, how are you going to deal with it? There are various ways in which we can, but one single way is to just drop the rows that have empty values. Also, sometimes in the data set, we might have columns that have no impact on our results, such as IDs. We remove those columns as well. We usually use data visualization to visualize our data through graphs and diagrams, and after analyzing the graphs, we decide which features are important. Next, come choosing a model. Now our data is ready to be fed into a machine learning algorithm. In case you are wondering what is a model, often machine learning algorithm is used interchangeably with machine learning model. A model is the output of machine learning algorithm run on data. In simple terms, when we implement the algorithm on all our data, we get an output which contains all the rules, numbers, and any other algorithm specific data structure required to make predictions. For example, after implementing linear regression on our data, we get an equation of the best fit line, and this equation is termed as a model. The next step is usually training the model in case we don't want to tune hyperparameters and select the default ones. So hyperparameter tuning. Hyperparameters are crucial as they control the overall behavior of a machine learning model. The ultimate goal is to find an optimal combination of hyperparameters that gives us the best results. But what are these hyperparameters? Remember the variable k in our algorithm which we learned earlier? We got different results when we get different set of values of k. The best value of k is not predefined and is different for different data sets. There is no method to know the best value for k, but you can try different values and check for which value do we get the best results. Here, k is a hyperparameter and each algorithm has its own hyperparameters. Next comes evaluation. You may be wondering how can you know if the model is performing good or bad? What better way than testing the model on some data? This data is known as testing data and it must not be a subset of the data on which we train the algorithm. The objective of training the model is not for it to learn all the values in the training dataset, but to identify the underlying pattern in data and based on that make predictions on data it has never seen before. There are various evaluation methods such as k-fold cross validation and many more. We are going to discuss this step detail. Prediction. Now that our model has performed well on the testing set as well, we can use it in real world and hope it is going to perform well on real world data. So what are the advantages of machine learning? The first one is it easily identifies trends and patterns. Yes, machine learning can review large volumes of data and discover specific trends and patterns that would not be apparent to humans. For example, for e-commerce websites like Amazon and Flipkart, it serves to understand the browsing behaviors and purchase histories of its users to help cater to the right products, deals, and reminders relevant to them. It uses the results to reveal relevant advertisements to them. The second is continuous improvement. We are continuously generating new data, and when we provide this data to the machine learning model, which helps us to upgrade with time and increase its performance and accuracy. We can say it is like gaining experience as they keep improving in accuracy and efficiency. This lets them make better decisions. Handling multidimensional and multivariety data. Machine learning algorithms are good at handling data that are multidimensional and multivariety, and they can do this in dynamic or uncertain environments. The next comes wide applications. You could be an e-tailer or a healthcare provider and make machine learning work for you. Where it does apply, it holds the capability to help deliver a much more personal experience to customers while also targeting the right customers. So now, are there any disadvantages of machine learning? Of course. The first one is data acquisition. Machine learning requires a massive amount of data sets to train on, and these should be inclusive, unbiased, and of good quality. There can also be times where we must wait for new data to be generated. The next come times and resources. Machine learning needs enough time to get the next comes time and the next comes time and resources. Machine learning needs enough time to let the algorithms learn and develop enough to fulfill their purpose with a considerable amount of accuracy and relevancy. It also needs massive resources to function. This can mean additional requirements of computer power for you. Interpretation of results. Another major challenge is the ability to accurately interpret results generated by the algorithms. You must also carefully choose the algorithms for your purpose. Sometimes, based on some analysis, you might select an algorithm, but it is not necessary that this model is best for the problem. High error susceptibility. Machine learning is autonomous but highly susceptible to errors. Suppose you train an algorithm with data sets small enough to not be inclusive. You end up with biased prediction coming from a biased training set. This leads to irrelevant advertisement being displayed to customers. In the case of machine learning, such blunders can set off a chain of errors that can go undetected for long periods of time. And when they do not get noticed, it takes quite some time to recognize the source of the issue and even longer to correct that issue. And when they do not get noticed, it takes quite some time to recognize the source of the issue and even long time to correct it. So, what is the future of machine learning? Is it harmful for humans or it takes the job of humans? Machine learning can be a competitive advantage to any company, be it a top MNC or a startup. As things that are currently being done manually, it will be done tomorrow by machines. With the introduction of projects such as self-driving cars, Sophia, a humanoid robot developed by Hong Kong-based company Hanson Robotics, we have already started a glimpse of what the future can be. The machine learning revolution will stay with us for long, and so will be the future of machine learning. We hope this video clearly explained the process of creating a machine learning model. To learn more about machine learning and how to make machine learning models, check out GoLogica's AI certification. If you have any questions or doubts, mention them in the comment section below, and we will have our experts answer them for you at the earliest. GoLogica covers the latest developments and innovations in technology that can be leveraged to build rewarding careers. You'll find career guides, test tutorials, and industry news to keep yourself updated with the fast changing world of technical and business. Thank you.